So we start by defining what a random experiment is. So suppose there is an analyst. An analyst says that the stock price of, say, a corporation, ABC Corporation, will either go up, it will remain the same, or it will go down. Now this is a random experiment and this is a thought experiment. So basically a random experiment will satisfy two conditions. So number one is there is more than one possible result, and number two is it is not possible to predict the result in advance. Now a possible result of the random experiment is called an outcome, and it is denoted by this small Greek letter omega. Now you can also talk about set of all possible outcomes. So the set of all possible outcomes is called the sample space, and it is denoted by this capital Greek letter omega. So let us do some examples. So we have already talked about one example, that is the share price. You could say that the outcome is price can go up, second outcome is price remains the same, third outcome is price goes down, and all three of them form the sample space. Now we talk about more examples, say coin toss. So it has two possible outcomes. Either there is a head or a tail. So sample space is h comma t, where h denotes the head and t denotes the tail. So this is all possible outcomes, which is just head and tail. Now we talk about two coin toss. Now there are four possible outcomes. So first coin shows head, the second coin also shows head, the first coin shows head, the second coin shows tail, the first coin shows tail, second coin shows head, then first coin shows tail, and the second coin also shows tail. So these are the four possible outcomes, and then you take all these four outcomes, so set of all possible outcomes, this becomes the sample space. So this capital omega is the sample space. Now another example of rolling a die. There are 6 possible outcomes here. You could roll either 1 or 2 or 3 or 4 or 5 or 6. So there are 6 outcomes here, and sample space is all these outcomes 1, 2, 3, 4, 5, 6. Then we talk about another sample space concerned with life of a bulb. So the sample space is 0 to infinity, and possible outcomes could be the bulb could just burn out as soon as you switch it on. So 0 is, say, one of the outcomes. Bulb could be on for half an hour, so you can say omega 2 is from 0 to 0.5. So it just burns out as soon as it is half an hour, or it could burn out at exactly 1 hour, so 0,1. So if it burns out just before it touches 1 hour, then you write it as 0,1. So there are infinitely many outcomes here in this case, life of a bulb, because it could burn out at any time. So the sample space is all the way from 0 to infinity. Notice that infinity is not exactly included here, so because we have a round bracket right here. Now we talk about events. So subsets of the sample space, so sample space is this big omega, these are called events. So for example, let us focus on this 2 coin toss experiment. This is our sample space. So this is the sample space, and we are going to talk about its subsets. So say exactly 2 heads. Now this is HH, so this is a subset. As you can see, HH is right here. At least one tail. So at least one tail means that there is at least one tail. So that is, you need to have either one tail or 2 tails. You cannot have 0 tails. So the first coin, if you toss it, you get a head, then the second has to be tail. So you have this is one tail. First could be tail, second could be head, this is also one tail, or both could be tails, so 2 tails. At most one head. So at most one head means that less than or equal to one head. So you could have 0 heads or 1 head. So first focus on tail. So this is 0 heads, so at most 1 head. Then you could have the first coin is tail, the second is head, so this is 1 head. First coin is head, second is tail. This is another one head. So at most two heads. So at most two heads means the number of heads has to be less than or equal to 2. So you could have 0 heads, 1 head, or 2 head. So this represents 0 head, tail, tail. 1 head is here, tail head and head tail both have 1 head each, and 2 heads is right here. So this becomes almost the entire sample space. So this is the entire sample space, as you can see right here. So what if you say, what is the event of 3 heads? So event concerning 3 heads in a 2 coin toss is a null set, because you cannot get 3 heads if you toss a coin twice or just toss 2 coins. Now the events can be classified into various types, So the first type is impossible and certain events. So a certain event is entire sample space. So a certain event is entire sample space. Sometimes you call certain event as sure event also. And impossible event is the null set. So this symbol also called phi or null set. So let us see an example. So for example, at most 2 heads is the entire sample space. So you say the event which is at most 2 heads in a toss of 2 coins, that is the certain event, because you have the entire sample space for it. So you can see the entire sample space is here. So it is the entire sample space, so it is a certain event. So at most 2 heads is a certain event. Impossible event, 3 heads. So the event that there can be 3 heads in a toss of 2 coins is an impossible event. Second, we talk about a simple event. So simple event, it has only 1 point of the sample space. So exactly 2 heads. This is just a 1 point of the sample space. So the sample space is 4 points: head, 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 tail, tail, head, tail, tail. So 1 point is just head, head. So this is a simple event. So another simple event we can construct D as, say, 2 tails. So this is another simple event. Then we talk about compound event. So compound event, it has more than 1 point of the sample space. So more than 1 point. So now you can see that this event B and event C. So B and C, both these are compound events. So this has 3 points. C also has 3 points. You could also construct another event, say 1 head and 1 tail. So 1 head and 1 tail could be first coin is head, second is tail, or first coin is tail and second is head. Now we talk about complementary events. So complementary event is such that you take an event and you take its union with its complement, you get the entire sample space. So complement of an event is this omega minus the event itself. And if you take union of both of them, you have the sure event, because you have omega on this side. So let us see this with an example. So for example, this is A and this is B. So focus on A and B. So A union B is the entire sample space. Yeah, so in B you have head, tail, tail, head, and tail, tail. You just add headed to it, you get the entire sample space. Also notice that A intersection B is the empty set. So because head, head is not contained in B. So A and B are complement to each other. So what is A complement? A complement is omega minus A. We also write it as omega backslash A. So that is from the entire sample space you take A out. So this is the entire sample space right here. So we're going to take head, head out. If you take head, head out, what do you get? You get B. You get head, tail, tail, head, and tail, tail, which is nothing but event B. So this is B. Similarly, you can see B complement, which is omega minus B. This is omega minus B is just A. So you take everything out which is in the B. You take head, tail, tail, head, and tail, tail out. What is left is head, head, and that is nothing but event A. So you can see that A complement is B and B complement is A, and their union is the entire sample space. So pictorially you can see it like this. So if this is the entire sample space omega, the entire rectangle, and this small set inside is A, then A complement lies outside A. So let us fill the color and see it. So we have colored A in yellow and we have colored A complement in green, and you can see A union A complement is the entire sample space omega. So A is yellow and the complement of A is omega minus A, which is this green part.